This is a planet, which is approximately round in shape. And this is an asteroid, which is irregular in shape. A common theme among those objects is the big ones are approximately round, while the small ones are irregular. But why? So let's try to find the answer. The answer to why the bigger objects are round boils down to the influence of gravity. For solid objects, gravity is opposed by the strength of the object itself. For instance, the downward force you experience due to Earth's gravity does not pull you into the center of the Earth. That is because the ground pushes back up at you. It has too much strength to let you sink through it. But the thing is, gravity is actually surprisingly weak. An object must be really big before it can exert a strong enough gravitational pull to overcome the strength of the material from which it is made. Smaller solid objects like asteroids therefore have gravitational pulls that are too weak to pull them into a spherical shape. Things get more complicated when you think about the fact that all objects tend to spin or tumble through space. If an object is spinning, locations at its equator effectively feel a slightly reduced gravitational pull compared to locations near the pole. The result of this is the perfectly spherical shape you would expect is shifted to what we call an oblate spheroid, where the object is wider at its equator than its poles. The faster an object in space spins, the more dramatic this effect is. Saturn, which is less dense than water, spins on its axis every 10.5 hours. As a result, it is much less spherical than Earth. To answer this question simply, the reason big astronomical objects are spherical or nearly spherical is that they are massive enough that their gravitational pull can overcome the strength of the material they are made from.